Hi, this is the Bien Air Electric Handpiece system. This was developed approximately 14 years ago to work in the North American dental market. It's an electric system, but it was designed for air units. So it's not a true electric system where you plug it into the wall like you would with a surgical unit. This unit was designed to give air units electric capabilities. And the way it works is the air actually trips a signal, converting it to electric capabilities. Now, the benefit of electric as opposed to air, as you know in dentistry, when you are depressing the rheostat, as you depress the rheostat more, the speed builds up on your air handpiece. But the problem is it's not consistent because you actually cut with torque. You don't cut with air and speed, you cut with torque. And torque, electrics have a tremendous amount of torque as opposed to an air handpiece. For instance, this electric motor has 100 watts of torque. Your air handpiece has in the neighborhood of about 14 to 16 watts of torque. So there's a tremendous power difference with the electrics. And that's what gives you the ability to go to depth, make one continuous smooth cut, and not have to go up and down and let the handpiece build up speed again, because this has constant torque and it is tremendously powerful in comparison to your air handpiece. Now, everything in dentistry can be done from this unit. You can do high-speed work, cutting your preps. You can do low speed, like gross caries removal. You can do endo. You can do surgical procedures like third molars or implants, all from this unit. And there are two units available. It's either going to be an external unit, as you would see here, which means that everything you see sits outside of the unit, your air unit. Or it could be an internal installation where all you would have is a touchpad and everything here would be internally installed. So all you would see would be a touchpad, and that would be your control module, your screen, everything. But from either an internal or an external unit, you can do high speed, slow speed, surgery, endo. Now, how it works is in the upper left-hand corner, you will see your gear ratios. And that would be, the motor runs at 40,000 RPMs. So if you want to run maximum RPMs to do, let's say, cutting a prep, you would select the 1 to 5 angle, take the 1 to 5 angle, which is signified by a red band, that is standard by ISO, attach it to the motor, and now you are ready to go, and that is a speed of 200,000 because a 1 to 5 angle is an increaser of 5. Now, that is a friction grip push button fiber optic handpiece. And if you want to slow it down, you can do it one of two ways. Either let your foot off of the rheostat, don't depress it all the way down, the speed will slow up, but you'll still have that tremendous constant torque. Or you can also just dial in the RPMs by selecting the precise speed range that you want, so that when you do depress the rheostat all the way, it'll be running the speed that you select. If you want to do slow speed with a right angle instrument, a right angle latch, or you want to do endo, you take off the red banded angle and you put on a blue band, which is a 1-to-1 direct ratio. And that will go ahead and allow you to do any slow speed latch work or endo. Now, in order to do that, the upper left-hand corner, you would select the 1-to-1. This does have auto reverse, auto forward, torque. Torque can be selected in two ways. Percentages, if you're doing endo, because endo files require the manufacturers will recommend a percentage of torque. That can be dialed in right on the screen. If you're going to be doing implants, this unit is also capable of doing Newton centimeters. So you can go ahead and do your implants. And that would be, the endo would be done from the 1-to-1 angle, which is a blue band. And if you were doing, let's say, implants, you would put a 30-to-1 motor, a 30-to-1 handpiece on the motor, and that would gear it down slow enough. It would take it down to about 33 RPMs, and that would allow you to place your implants. If you wanted to do third molars, you would put a 1 to 2 surgical angle on it, which would let you run at about 80,000 RPMs, and that is where pretty much all surgeons will run to do third molar extractions. From there, if you wish to deliver sterile water, we can also supply a separate peristaltic pump which will deliver sterile bagged water, or whatever procedure you want to irrigate during surgical procedures. That's entirely up to you. Pretty much that's it. Your day-to-day maintenance is the same as if you were using an air handpiece. Once you are through with your procedure, you go to sterilization area, you wipe the handpiece down, you go ahead and you spray it with what we call lubrifluid, which is a lubricant, and then you go ahead and expel the excess by either putting it on an automated system or reattaching it to the motor, depressing the rheostat and expelling the excess. You bag and sterilize. And that's pretty much it. The long-term maintenance is different because there are no turbines. These are gear-driven, so you do have to have the gears rebuilt about every 15 to 18 months, and that's a cost of about $300. So if you compare that to a turbine, you're spending less money in the long run. Other than that, that's pretty much how the electric system works. This system was actually rated by the American Dental Association. In an independent study, they rated this #1 for all the features and benefits that it would be able to give the practice. And that's pretty much it. Thank you.